Okay, in this lesson we're going to review adding and subtracting polynomials. And if you remember from previous algebra lessons that adding and subtracting polynomials just requires you to combine the coefficients of the variables that have like terms. Now, one of the things that we're going to do maybe a little differently here is that in doing this you can either use a vertical or a horizontal format. Now, what I'm going to tell you is you decide. You decide what works best for you. We're going to represent both of them, and at that point you can kind of see which ones you prefer the most. So let's just take a look at example number 1. If we're adding polynomials, the first thing that we've got to be very careful about is that we stack like variables on top of each other. And what I mean by that is this. If you can see this, we have x to the third, and x to the third. We have x squared, and x squared. But in this next one, we only have one x available. The second polynomial doesn't have an x term, so we would need to leave that blank. And then at the end, we have all of our constant terms stacked up. This is not a problem whenever we're dealing with a horizontal format, but when we're dealing with a vertical format and we're stacking one on top of the other, we have to make sure we leave spaces open and we get all of the like terms stacked on top of each other. And then at that point, all you would be doing is you would be combining like terms. So you can see in this first one we have 3 and 1 is 4, 2 and negative 10 is negative 8, negative 1 and of course 0x is still going to just give us negative 1x, and then negative 7 and positive 8 gives us a positive 1. So this is our simplified expression. So again, in this time we're dealing with polynomial expressions. We're not dealing with functions at this point because there is no equation given to us. It's just two terms that we're trying to put together. Now, the way that most of y'all have probably seen it more often than not is like B in a horizontal format, where we have one polynomial added to another. In this case, since we're dealing with addition, we just simply drop parentheses. And so you can see we drop the parentheses. And now all we're trying to do is combine like terms. So you can see we have 9x to the third power. There is no other 9x to the third power. We have 5x squared. There is no other squared power. But here at the end we have negative 2x and a positive 12x that we can combine together. And we have a positive 1 and a negative 4 that we can combine together to come up with our simplified polynomial expression. So either way that you like it, no matter which way it's given to you, you can convert it either way. So you can see sample problem number 1. It's given to you in a stacked method or a vertical format. If you want, you could simply take this and add it. In this case, we have a negative 3x squared minus 6x minus 1. So you could simply add it across in a horizontal method as well. So either way that you'd like to do it, that's fine at this point. So here in the stack method, you can see we have x squared on top of x squared. So 5 and negative 3 is going to give us 2x squared. We have a positive 1x and a negative 6, so that's going to give us a negative 5x. And we have negative 7, negative 1, which is going to give us negative 8. So 2x squared minus 5x minus 8. And of course we could do the same thing over here. We could take 5x squared and a negative 3x squared, and when we put those together that's 2x squared. We have a positive 1x and a negative 6x, which is going to give us negative 5x. And of course negative 7 and negative 1 is going to give me negative 8. So either way we come up with the same result. So you need to kind of figure out which one works best for you. Now, example 2 goes into subtraction. Now with subtraction, if you recall, from doing this previously, it's important that when we subtract an entire polynomial expression that we subtract the whole thing. And what this means is that we're going to need to distribute this negative to every part in here before we can drop the parentheses. Now if we're in a in a vertical stack method, once we drop the parentheses, we're simply combining the like terms, and we make sure that our x thirds, x squareds, our x's, and our constant terms are all stacked on top of each other. So that's a very important part of this process. Now, also, if we're in a horizontal method, like we are accustomed to, you recall we still need to distribute the negative before we can drop the parentheses. So that's extremely important that you remember to do that. So distributing the negative on when we're subtracting polynomials is extremely important. So go ahead and pause the video for sample problem 2 and work these two subtraction problems. Okay, so let's take this first one. I'm going to distribute the negative, and after doing that, I'm just going to simply rewrite everything with the negative distributed. In this case, that's going to give me negative 5x to the third. That's going to give me a positive 1x squared. Keep in mind that's understood 1. I do not have an x term, so then that's going to give me a negative 17. Notice I've left a little gap there where the x term should be, so that just basically is going to be represented by a 0x. That's extremely important as a placeholder. And now I'm going to combine like terms. 3 and negative 5 is negative 2x to the third. Positive 8 and positive 1 is a positive 9x squared. We have a negative 1x and a positive 0x, so that's going to give us a negative 1x. And then that's going to give us negative 22. Okay, so that's a stacked method or vertical method. And of course, the second one, we're going to be required to distribute the negative first. So I'm going to be left with 9x fourth minus 12x third plus x squared minus 8. Notice I just took everything out of the parentheses in the first term. But in the second term, I actually had to distribute that negative, so I have negative 3x to the fourth, a positive 12x to the third, and a positive x. Now all I need to do is combine like terms. So I have x to the fourth and x to the fourth, so 9 minus 3 is going to give me 6x to the fourth. I have x to the third and x to the third, so negative 12 and a positive 12 actually ends up eliminating each other. So there's no x to the third term here. I have a positive x squared, so that's a 1x squared. And then I don't have an x squared term in blue, so that's just going to be plus x squared. I'm missing an x term in the red one, but I have an x term in the blue one, so I'm going to bring that x term down. And then last I have negative 8. And so now we have combined all the like terms, and we've subtracted these polynomials. Okay, so that's a basic review of adding and subtracting polynomials that you've done before. Now you can see it in a vertical method and a horizontal method, and you need to decide which one of those methods works best for you.